Hello everyone. Hope you are doing well. I'm Ganesh Madhida. So today I'm going to start a new playlist, which is related to embedded coding, coding in embedded systems. That's the name of the playlist. So welcome to the coding in embedded systems. So my question is, are you curious about how real devices store and process data? That's one thing. Because if we learn something and if it faded away afterwards, it's of no use. You want to learn it the way it was actually being used. You need to understand why the programs are used. So this series is actually targeting that scenario where you can understand where it was actually implemented in the embedded systems. So whatever code we are gonna do, we have an explanation where it was actually used. And for today, we'll have this concept data types and memory representation going, and we'll take around 10 questions here, and we'll solve them. Questions in the sense coding tasks, we'll solve them and we'll understand how things goes. And I have represented these 10 questions here itself for easier convenience. If you want to take a screenshot, that's always okay. And you can stay with me to understand these 10 questions, and we'll go in a very basic way and very understanding way. Okay, let's get started. So first question, define a struct to, let's go question by question then. So define a struct to represent a sensor reading, temperature, humidity, and timestamp. Okay, that's what they asked actually. They asked to uh, have a structure defined to represent sensor readings. Oh, the sensor, wait, sorry. Okay, so sorry for that. Mm, so we definitely have a sensor, and a sensor has readings. One is temperature, other one is humidity, and timestamp is actually taking up the time where which the reading has been taken. In simple, we can understand this way. So we have these three parameters. They want to put it together. So how I can modify this question? There should be a way to actually modify this question, right? There should be a way to modify this question. So the question how I modify it is, how do we keep temperature, humidity, and time from sensor together in one package? Can I call it as package? And I want it to be neat. I want to be organized. One organized package, like a book wrap. So in coding, how would you do that? Because why we need it is, this is an example. We use sensors in embedded systems. So we get data from there. Let's suppose we have a sensor called DST11. You guys might be aware of it. That's a temperature and humidity sensor. We get a sensor like this. So how will you do that? Have you ever thought of it? So the basic thing we can do is, the first thing is we can actually have maybe I will take a temperature as a float because it can go float temperature this way, this one way, and float humidity, and maybe time is an integer. I would go like in type time stamp. Let's go it this way. So this is one way actually I can do this. And what is the other way around? There should be other way as well. So there should be other way as well. So what is the way? What is the way in which I can do this? So think about it. I already gave the hint over there. Define a struct. That means I want to define a struct. Struct means structure. Structure is a data structure. Is a way where we group the data together in C language. It's one of the feasibility. So what we want is we want to understand that if you know how to do this, instead of having different variables, we need to do it in a single term. So I mean, I did this just to identify you that they want to define a struct, and this is one of the syntax simple way to learn it. And struct need to be named. Maybe I will write a sensor data, sensor underscore data. That was the name of the structure, and this one will always have. This is like more or less template. So I want to define I whether I can do aliasing or I cannot. I need not do aliasing. Uh, it's more or less like this is a structure for a soap. It can be santur soap. It can be dough soap. It can be any soap. That's what the naming of it. So this is how you actually do it. So we don't just do it like this. We'll just open online GDB and try this. So I'm opening a new UDP here, and just a minute. I think my DPI is quite high. So I will leave this as it is. I will write struct name is sensor underscore data. I'm not using type def and stuff here. For time's sake, I'm not using it. And as we discussed, float, temperature, that's one thing. Float, humidity, that's other thing. And in here, I will take it as in timestamp. For just I'm taking it as in, we'll learn the rest of the things later on. So I'm gonna close it. That that's how structure is done. That's what we need. Our question says simply, just understand the question. How do we keep? He's just asking a question. I'm just asking you a question. How do we keep it? So you have solved the situation here. You keep it using structure. So let's see some behavior of structure as well. Let's see if it runs. It runs. So you all know the statement called size of, which returns size of. So let's see what is the size of struct. Size of always returns number of bytes. So it's usually going for integer. And size of, because I already named the structure as sensor underscore data. So I'm gonna use it that way. And let me see what will be the size. So here it's not working because sensor underscore data is the structure name, but we need to tell. If you go to a shop and say, give me a soap, he don't understand. You need to give it a name and you need to create one soap out of the way. You all know how to write exam paper, but you need to know what subject need to be written, right? That's all. So we need to declare one. That's one thing. So in order to declare, we need to extract, we need like in text, likewise sensor data. This is the declaration of it. That's how we do. And sensor one is the name. So let me check if I can do sensor one, if I can do it like in general. So I can do it, but there was some other issue. That's not an issue. Usually, size of will take long parameters. So I just need to put it as LD. So if I do this, you will see the size, which is 12. It says it's 12 bytes, which means this float is taking 4 bytes. Mine is a uh, um, mine is a 64, but it's by default taking 4 bytes. I mean, it's the compiler which takes 4 bytes, and integer is as well 4 bytes. But you also know there is one more thing here. You can limit the stuff. We'll cover most of the questions here. There is a include file called stdint.h, which gives declarations for each unsigned integer type data types. So you went 16 underscore t. Let me do this. So let's see what it does. Because I'm actually this defines that it can only use 16 bits. Okay. So let's see. So yeah, this again goes for 4 bytes. Yeah. So let's try you went 64 bit. Let's see how much it goes. 16. So it goes for 88 bytes. So we can also do this way. I increment it, or we can make it float 4 3 12. Again, it will go by 12. Or we can make it long, and again it will go by long is just a longer version of integer. Okay. So one thing you need to understand that if I do it, you unsigned int, that's a different story. Why 8 underscore p is not, this was just 1 byte. You understand, this was just 1 byte. So why it was not actually 9 bytes, why it is 12 bytes? So that's a story. We'll cover it later. But up till now, this is how we write it. And to access individual variables, it's as simple as just a dot. Just put a dot and call that variable temperature. For suppose. So I want to have the size of temperature. So size of temperature is 4. And if you want to store something in the temperature, right? Sensor one dot size of temperature. This will be like sensor one dot temperature equal to, maybe I was adding 55.365. Okay, it's a float, right? So I want to leverage that, and I want to print percentage f because it's a float, and I want to implement new line character here because it's gonna be messy. So it's a good practice to have new line characters if possible. So that would, if it's possible. It's possible mostly, but if it's possible, it's better. So sensor one dot temperature, and this is how we solve the first. And if I run this, so see, and this is something you need to know. Y002, Y002. Let's make it 0. See what will happen. Let's make it 0 and see what will happen. So it's 000. That's just comes to the floating point calculations, Y002. Okay. Usually it comes with the floating point calculations. That is not an issue. Again, that's not gonna change your out. Okay. So let's go to the second question here. So the second question is, uh, use a union to overlay 32-bit integer and a 4-byte array write function to set or get each. So, so what is union basically? So, if I understand union from my perspective, union, let me write it somewhere here. Union is like a window. You see memory. Union is like a window where you see memory in different sense. Uh, so the thing is, for suppose if you have a if you it's more or less you're processing so many things, like you are having a window and you are seeing many things over in it. but end of the day it comes out through one door only. It's more or less like an entrance to an examination hall. You have many doors to the examination room, but only one room is open, or only one place is there. So even though you have those many places occupied, you can only have one place. So your place is only one, which is the assigned one. The other way around is um, in a simple. Hmm. So if you are having a shared seat in a car or somewhere or in a elevator, so the example would go like, let me write down. Sorry, it's oh. So the example would be, I mean, just I will call out a difference between, uh, right. So I will toll out some difference between structure and union, so you may understand things now. If structure has one, two, and three parts, so how many we will say? We'll say one plus two plus three equal to what is the value of this box? Usually six. That's structure. But in terms of union, right? In terms of union, we'll say like the same way. Both are same. Both are storage things only. But the same case is highest variable will give the value of union. So that's more or less it's used for uh, union is actually used for one case sending data over networks. Okay, or talking to an hardware. It is completely useful over there. So let's look at this problem. What we need. So we need to create a 32-bit integer overlay. Okay, we need to create 32-bit integer overlay and a 4-byte array. And it's more or less you are saying use a union means we need to create an union. And what should be there inside it? 4-byte array and 32-bit integer. And what are the functions we need to write? Set or get each. Okay, let's try to write it down first. So let's write it down first. So let me save this for time being. I'm gonna save this. Okay, I'm gonna write our generic code. It's specifically mentioned it should be 32 bit, so that's why I'm using stdint.h. So then I would write general. It's a good practice to have this ready. I have a habit of writing this way. It should be different for you. But usually I will set up the main first so that I will have a clarity that what goes with. So here I need to create a union, just like how we did for structures. We do it for union as well. So I would say overlay, and I will name it as overlay because we have it. And as mentioned in the code, we have to have two parameters here. As mentioned in the code, we have to have two parameters. One is 32-bit integer and the other one is 4-byte array. So let's do that now. Let's take over that thing. And I am taking unsigned entry event underscore t. And I'm gonna name it as integer. And that's one character. And other one is 4-byte array. What type of array? Have they mentioned any array? But they mentioned it's a 4-byte. 4 byte means 8 bit. So you can use uint t underscore 8, 8 underscore t. So, so I'm going to use this, and I'm going to name this as array as well of 4, or I'm going to name it like ARR of 4 to not have any clash. And I'm going to name it as number. So that makes more sense. And as we know, we need to have a colon here, semicolon here for the sequence to be. This is a block of code and we are having a colon to end this. Okay. I hope you understand that. This is one way. We can use other way as around as well. So, okay. So now what is it? Uh, what exactly is it doing here? Okay. How exactly we can use? Our job is having, we created a overlay here. So what exactly we can do here? Okay. So first suppose I created a union uh, v1, maybe test one. I created a union here. Okay. And in test one, I have the same parameter, right? Which is actually number, because this is basically uh yeah, I mean overlay. Because I can't create a union which is not pointing to anything and put it like this. I need to define it. We already defined it, so I'm using union overlay test dot number, test one dot number equal to, or I can just make it test. So test one is gonna make you go little overhyped for this problem. So test one dot number equal to, I'm gonna assign some 32 bit because the number is 32 bit. So I'm gonna assign something like 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that's a 32 bit. This is 32 bit number. Okay. So that is 32 bit number. And what I'm gonna do now is, which is useful. So, so what I'm gonna do now, uh, basically I want to, what is an overlay basically is I want to have each byte from this 32-bit integer, 4 byte integer to be taken off. So what I do was, I would just test dot arr equal to, I'm gonna do what, right? I'm gonna assign it for test dot number. Okay. Now I will try to print percentage d comma test dot arr of it has an index, maybe 0th index. I'm gonna print this. So let's see how it works. So what happened now? Uh, Wait a second. That is yeah. This should be actually in this main.c. Sorry for that. And this need not be having here. I'm gonna delete that whole code. Okay. So I'm gonna run this now. If we have an array, we'll see. We'll take it. Okay. So yeah. Sorry. We need to go ahead. But this is the first thing that we think about. In this scenario, this is the first thing that we think. There is one problem here, which is syntax. Syntactically, it is wrong. We cannot assign something to the array directly. We cannot assign some value directly to the array. We have to assign it either by memcopy or a loop through individual indexes. So if I say, for suppose, index 0, if I say index 0, what will happen? Let's see. So what happened here? It happened in as 120. It printed 120, right? So what about index 1? Let's see that. If I do this, so it's again the same. It's printing each bit over there, and it's actually doing the same. But without even doing it, without even assigning anything over, let's try this. What will happen? So what happened here? Uh, the number 86 has been printed over here. So let me do 0th. So 0x is 120. But we are missing one thing. What is this value? This is a hex value. And what we are printing? We are printing an integer. So these values has been converted into those. So for suppose I remove this. That's why I was not speaking on that. I remove this and let's see. So now we are getting 0 because it's going from less, usually least significant order. It was going from there. We have the byte ordering and stuff, but we don't care. But why this is happening, we haven't assigned. So as I said in the previous, the thing is structure takes the largest variable as its complete memory. It has only one memory, which is the largest memory. So that's where the remaining is sitting over. So when the other element is not accessed, not given any value, it will usually start from the memory where the first number is stored. So it starts from the memory of this. So the size of the union will be 4 because this is 4 byte. You understand this is 4 byte and this is 4 byte. This is 4 byte. So the size of the union should be 4 byte because 4 is the largest and it will share the same memory location. So if a number is already having something, if array is not having something, more or less number and array share the same thing. It's more or less you brother and you share the same closet, and since you both are sharing same closet, it's possible that you both will be sharing the clothes also. So sometimes he can take your clothes and stuff if he's not having anything that way. Usually that's more or less like bonding. So this is how you do the overlay. You can, without writing a very complex program, you can actually extract the bytes using union overlay. So this is the problem explanation. So if you have any questions, we can go from there. We go to the third one. So this is a very important aspect here. Bit fields. This was asked. This will be asked because this is very required thing. So we already know structure. We already know structures. So usually where we use structures, we use it for transmission purposes, sending out the data or packing the data properly. So why we need bit fields? So it's more or less like bit fields is more or less like if we have a register. If we have a register and we need to access only one bit of the register, okay? But the lowest you can go is 8 bit, and it's a waste of memory. If you are only accessing one bit, 8 bit is waste of memory, okay? So for suppose another example would say is I would say the same sensor example, we can take it. Same sensor example. For suppose there is a sensor, okay? Maybe proximity sensor, proximity or IR sensor or something. So the main objective I want from it is yes or no. Yes, if there is some person or no. I don't need any other parameters. I just need sum. So if you take a variable, it will either get 1 or 0. So for 1 or 0, if we take a binary of 1, 0, 0, 0, 0, if it's 8 bit, 1, and it's completely 0 for 0, and one more 0 would have. So for this thing, the only thing that appears here is these bits. So 0 bit, that significance is coming from this bit. So why we need that much? We don't need it. For the same sensor example, you can use something called bit fields, which actually do what, right? It will reduce the use of the memory. Or in simple, if I say bit field, bit field allows uh, wait, just a moment. Yeah, yeah, got it. Bit field allows you to create separate variables for each bit. Okay, so allows you to create, or it's not creating, to treating. Usually it's treat each bit as a variable. It's more or less like uh, if you go to if you go to a juice shop, if there is a kid with you, he won't serve the kid free glass, right? He will also ask the payment for it. So that's the thing. If you want, maybe the kid will have the smaller package, you will have the bigger package. So that's the thing here. So you have this register and stuff which has only one bit to be used. That's all. You will see this. We'll see this in the register pro level programming. But let me write it afresh. Uh, dot h. Okay, and std. We don't need lib at the moment in dot h. Okay, so this is the way we do. Uh, so it's better. So I have a habit in main. I always write in main. Initialize it as a return of 0. That's better. We don't forget it, or we don't have a overhead. Those things step is actually complete and the code works till now. So we write a structure, and the structure name is sensor, maybe some sensor value. Okay, and I would say event 8 underscore c trigger. Maybe I was checking if it's trigger or not, and maybe I was checking event 8 underscore t error, error flag. I was checking. So these two are just flags. We need to close this first, because why I'm doing this is whatever we write, it should go errorless. So it should go errorless. That's the main project. So if we do like this, you will find a way for yourself to find errors much easier. So always make sure whatever you write it to the partial complete in the syntactical level, so that you won't make this mistake again and again. So that's why I was always having this emphasis over closing the phrases and stuff. So we have this, and this is actually using 8 bit, but we need 1 bit only. Uh, we need 1 bit, but we have 8 bits. It's more or less like for you itself to go to airport, you are booking a 8 chair SUV. Okay, that's not making sense. So you need to share it with others, or you need to tell him that I will come on sharing or something like that. So that makes work. So this thing works actually with an operator called an operator. Like you guys see here, that's a colon operator. And you need to mention how many bits I need to treat it as a integer. So what I said, right, this trigger will be treated as a 1 bit integer. So we'll see that. So for suppose error also 1 bit. So for suppose if I want to print, if I want to, that's a structure, right? Structure, struct, sensor as well. Maybe I take this. And I'm gonna print size of printf, size of, size of trigger is percentile d. Okay, and we put it long integer because size of requires that. Size of. So let's see that if it works. If it works, it works. If it doesn't, it doesn't. But experimentation is key. So here's the experiment we do. So the thing is, size of is applied to a bit field. It won't work because size of only returns. Usually the logic is size of only returns bytes. It won't work on bits. So size of usually won't work. But what if I say size of works on S1? Let's check that as well. Because bit fields are anyway involved in it. But it works because see, this is 1 bit, this is 1 bit. Usually the entire structure will take 8 bit because it will map the rest of the bits in padding and stuff. Okay. So that's how we can do this, or many ways to write this. We can use type def, we can use name here, namespace here, but I'm just you going minimal here. So I hope you understand. If you have any questions, you can shoot it out in the comment section. So this is a very important question. So write a function to print binary representation of unsigned integer. So binary representation is if we take 10, uh, my handwriting is bad. Don't please think bad about it. It's what that came up. So so if I take something like 10 and its binary representation is uh, 0, 1, wait, yeah, 1, 0, uh, wait a moment, something is not working here. Yeah, 1, 0, 1, 0. If it's 8 bit, 0, 0, 0, 0, 1, 0, 1, 0. So let me go some deep how it actually happens. Binary means 2. It was having 2 parameters. So for suppose if we have 10, we divide it by 2. So sorry. Uh, yeah. If we divide it by 2, the uh, like quotient is the divisor is 5, dividend is 5, and it's 10, and the remainder is 0. And again, it goes by this. We take the 5, we divide it by 2, and it will be 4, and the remainder is basically the remainder is 1. And we take 2, we have 2 here, right? We take 2, and we divide it by 2, and the 1 is the quotient, and 2, and the remainder is 0. And we take 1 because 1 is the like a multiplier, right? Which is multiplying with 2. So we take it 2, and we take it 1, and the dividend is 1. So we have to go from the last to first. So it will go like 1, 0, 1, 0. That's what the binary representation of 10. So usually we can use the same logic here. We can use the same logic, but in a very like code values. Okay. So we'll continue doing the problem now. So that's a simple problem. That's not gonna take much time. So here what we need to do is we need to devise and take this. That's one way. And there is other way to do this, which is using these statements which we need. So let's look at that. I'm writing a function in binary and it take an argument called int x. Maybe just we don't go into pointers and stuff now. And as per the habit, int main and zero. So our main agenda is to create a function and call it inside this, and I want to ensure that I use a value which is binary of, maybe I will pass 10 only. Okay, I'll pass 10. So here what I do was uh, I want to have 8 bits. I want to have 8 bits to be printed, or I want to have whatever bytes. If it's an integer, 32 byte, 32 bit, 32 bit should be printed for me. For int, I want to run a loop. So for int I equal to, I want to run a loop uh, size of x, okay, whatever the size of x into 8. So that's what it, but the indexing starts from 0, so I'm gonna minus it with 1. So how it goes is if size of integer is 4, 4 into 38, 32, 32 bit, but index starts from 0, right? So usually needs to go, I mean, in the loop, I will go from that way. Or I can do it like this as well. And I greater than 0. I is not equal to 0, I greater than. And I minus minus. So I will iterate 32 times here. Okay. I will iterate 32 times because I is an integer. If it's a character, that's a different story. If I want to print a character and inside bits, that's a different story. But if it's a integer, this is the story. And I'm gonna printf. Printf is a function which we learned in the our video in the other platform, other uh, playlist. So how printf comes and we actually opened up stdio.h. You can always view that video there. But here, how to print the bit is I will print the integer of it and I will print what, right? X, right shift by I, because I want to right shift that many positions so that I will show you by an example. Actually, I will show you by an example how this happens. And one. So this actually prints it in the reverse order. I will show you why I did this explicitly. And I want to have a new line after this done. So I'm going to print a new line. So there are ways to do it, but this is one of the way. So this is one of the way we can do this, but there is the catch 101. This is happening this way because why it is happening is we are not actually having the I as 0 and it's stopping at I x redshift 1 only. So that's the reason we are having this issue. I will tell you. I will tell you with an very beautiful presentation of the same. Uh, so I will make it equal to 0. I reduce it there 1 and increase it 1 here. So we have the correct representation. It's 1010. And it's if I want to print it with a tab, I can do that. That's very minimal. Or if I want to print it with a space, I can do that. That looks much better. So this is how we can do this. Okay, let's look into the uh, much more analysis of it. Okay, so let's take an example. Let's take an example. Let's take an example as 10, which is indeed let's take it only for 8 bit 0000 1010. That is it. So as per my logic, let's only consider I'm learning a for loop for I equal to 7, I less than or equal to sorry, greater than or equal to greater than or equal to 0, I minus minus. So it will be incremented, sorry, decremented by this value. And here our x equal to 10, which is 0000, this one. And in the first iteration, I equal to 7, right? So I'm gonna do what, right? X right shift by 7, and I'm gonna end it with 1. So what actually happened? I right shift it by 7. 7 positions it will right shift. So what will remain here? If I right shift it by 7, this will go to 7 positions. 3, 4, 5, 6, 7. This position, this will go. So this will go to this position. And it will be ended with 1, which is indeed written like this. So this is and this is indeed 0, 0 and 1. You know the truth table. For ending the truth table is different. 0, 0, 0 and 0 is 0. 1 and 1 is 1. 0 and 1 is 0. 1 and 0 is 0. So that's how this works. So by this way, we are actually getting this bit out of this. We are actually getting extracting this bit. And when we loop around, we get every bit. Because if we are doing this operation, that's only confined, that's an operation. That's not changing the value in the x. We are not using equal to value, equal to operator here. If you are doing this, it's just an operation. Okay. So that's how we do this. I think we covered until here. So let's look at mm, so I want to divide this into two sessions. We'll look into number 5 to 10 into 2. That's a very simple. If you understand this thing, that's gonna be very simple. You can take these questions and let me know if you have any questions. So uh, we can go by that. This is where we are now. So yeah, thank you, and hope you enjoyed the session. And please take over the subscribe button and notify button for me. Encourage myself. Thank you.